Well, let's look at some more specific examples to get a handle of what's really going on here. So again, we're talking about the chain rule, and my first example is to define f as a function of u, okay? And it's just defined as u squared plus 3, that's it. Just think of u as its input, that's all that matters. So u is f's input, and all I do with that input is square it and then add 3 to it. And u in turn is a function of x, all right? And u defined as its input x is just cube it, cube the input, x cubed, all right? And so if I can think of, if I want to find the derivative of f, okay, with respect to x, then what I need to do is f is not a function of x explicitly. We can see that here. It's a function of u. So to figure out how f changes with respect to x, I have to first find out how f is changing with respect to its input, which happens to be u, and then find out how u is changing with respect to its input, which is x. Okay, so I have a chain of functions here. Really what's going on here is f is a composition of two functions. Okay? And so what I do is I have to find out first how f is changing with respect to its input, which is u. Multiply that by the derivative of u with respect to its input, which happens to be x. Okay? And again, if we cancel out the du's, we get back to df dx. So in order to compute this, I just have to find the derivative of f with respect to u. Okay? Just ignore u, what u is for the time being, and we just think of f as a function of u alone. Okay? And it's a normal derivative. We're just going to take care of the power rule here. Derivative of a constant is 0. Okay? So when I take the derivative with respect to u, I just get 2u, and the derivative of 3 is 0. And I multiply that by the derivative of u with respect to x. So I'm ignoring f now, and I'm only thinking of u in terms of x. And the derivative of this function with respect to x is just take the derivative. So we're doing the usual power rule here. And so what happens is this is just 3x squared. Okay, so this is this piece, this is how f is changing with respect to u, and this is how u is changing with respect to x, 3x squared. Now recall that I'm looking for the derivative as a function. In this case, I'm looking for the derivative as a function of x. So I want this all in terms of x's down here. And so to do that, all I do is replace u with its rule in terms of x, which is I cube the input, which is x cubed. Okay? So I rewrite this as, this is 2x cubed multiplied by 3x squared. Okay, so df dx is this quantity. And I could simplify this a bit. So f prime with respect to x is going to be 6x to the 5th power. Okay? And that is the derivative of f with respect to x. And notice again, because f is not a function explicitly of x, I have to do a chain of derivatives, because really this is a composition of two functions. And I can rewrite this, by the way, as this is the same thing as f of u of x. Right? It's a composition of f, in fact, of two functions. In particular, it's f composed with u, which is in turn a function of x. Okay? So this is f composed with u, or f of u. Okay? Fog, in this case it's fau of x. Okay? So f composed with u. And again, all I'm doing is computing the derivative. It's a chain of functions, therefore it is a chain of derivatives, and thus the chain rule.